All right, so in this video, we're going to be finding exact values of trigonometric functions given one value and the sign of another value. Giving us a sign of that other value is going to allow us to figure out which quadrant our terminal side of the angle is in. So we're going to be given the sine of theta is equal to 1/3. And we're also going to be told that the cosine of theta is negative. Okay? So what I want to do is I want to find the exact value of each of the remaining 5 trigonometric functions. So I need to find cosine, tangent, cosecant, secant, and cotangent. All right, so first thing I might do if I was you is I would draw a circle. So try to draw a picture. You know, maybe this will help you out. I know it helps me out so I can visually see what's going on here. So I have a positive sign. Okay, so what do I know? All students take calculus. Okay, so I know it's either going to be in the second quadrant or the first quadrant. Okay. Now, since cosine is negative, that means I can't be in the first quadrant, so that tells me that I've got to be in quad 2. Okay, so I know somehow when I'm rotating around, my angle is going to be somewhere over here. Okay, so the sine value, right, it's x and then 1/3 over here. Okay, oh well, actually I'm sorry, it's actually 1 here. All right, so if we think about this, we're not told this is a unit circle, so we have to assume it's some radius r here. So remember, sine of theta is defined to be y over r, and if it's a unit circle, then it's just y. Okay, so the y value is 1. Now r, we know, just from based off of this here, it's 3. So now what I'm going to do is I'm going to use Pythagorean Theorem to figure out what's going on here. Okay, so let's see what's going on there. All right, I need to figure out this x. I know r and I know the y. So how do I use the Pythagorean theorem here? Well, the y is 1, the r is 3, and I'm looking for this. So a squared plus b squared equals c squared, okay? So if a squared plus b squared equals c squared, now what's going on here? Well, 1 squared plus x squared, those are my 2 legs right there, equals c squared. That's the 3 there. So 1 plus x squared equals 9. So minus 1 from both sides, I get x squared equals 8. When I take the square root, I'm only looking, let's see here. We got to figure out, are we looking at the plus or the minus? Well, what do I know about x? Okay, x is what? It's negative. It's less than 0. So what do I know? This x value here is going to be the negative square root 8 value. That's the one that we're going to pick. Okay, now I can simplify this a little bit because 8 is actually broken down to 2 times 4, and the square root of 4 is 2, so this is 2 square root 2 there. So my x value, right, this x value here is negative 2 square root 2, and it makes sense since we're going this way in this direction, the x would be a negative 2 square root 2, okay? And we're going up 1, all right? Okay, so what do we know now? We actually can calculate the cosine of theta. The cosine of theta is going to be x over r, which is negative 2 square root 2 over 3. All right, the tangent of theta is y over x, which is 1/3 over negative 2 square root 2 over 3. Keep, change, flip. What's that going to get me? That's going to get me what? That's going to get me 1/3 times, and then 3 over 2 square root 2, and then the negative. What happens? The 3's cancel, and I get negative 1 over 2 square root 2. If I simplify this, multiply top and bottom by square root 2, I'm going to reduce to, it looks like square root 2 over 4. Okay, square root 2 over 4 going on there. So that's the tangent right there. Now I need a couple more. The cosecant, okay, cosecant theta. This is 1 over y, but y is what? Okay, so y is 1. Okay, actually it's y over r, right? Well, y over r is the reciprocal of sine. So that's 3 over 1, which is just 3. Okay, no biggie there. Now, secant of theta is equal to r over x, the reciprocal of cosine. And that's going to be what? That's going to be 3 over what? Negative 2 square root 2. Okay? Multiply top and bottom by square root 2. I get 3 square root 2. So that's negative 3 square root 2 over 4 is what that looks like going on there for the secant. All right? Now, maybe that was a little challenging to follow, and I totally understand that. So what we're going to do, we're going to work another one kind of similar to this, okay? Very important that you guys get this concept. You know, it is a little bit at first. You know, but before we go to the next one, maybe we should try to do this problem using identities, okay? So let's you know, try to tackle this problem in another way. So get sine theta equals 1/3 and cosine theta is less than 0, okay? So let's use identities. So same problem, but we're going to use identities here. All right, if I did this, well, what identity links sine and cosine together? Well, it's the Pythagorean identity, sine squared plus cosine squared theta equal to 1, okay? Now, if we can get cosine theta, then we can get the others, right? Because if I know, you know, sine theta is equal to y over r, right? And so what does that tell me? That tells me that y is 1 and r is 3. All I have to know is x, and once I get x, by golly, I got x, y, r. I can get every other, all the other 5 trigonometric functions from that. Okay, so, you know, your one route is using Pythagorean Theorem, and the other one, you know, you can use your identities. Well, what are we looking for? Okay, we're trying to solve for cosine, right? So let's solve this equation for cosine. So minus sine squared from both sides. What do I get? I get cosine squared theta equals 1 minus sine squared theta. Okay, when I take the square root, I get a plus or minus. But what am I looking for? I only care about the cosine that's negative. Okay, so I use that same technique, right? I look at the negative branch of the square root. And now I'm going to be able to get my answer. Well, what do I know? The sine of theta is 1/3. So sine squared of theta is 1/3 squared, which is 1/9. So this is equal to negative, and then square root 1 minus 1/9. Now, 1 minus 1/9, that's negative, and then that's what? If this was 9 over 9, that would be 8 over 9. If I square root the numerator and the denominator here, I get square root 8 over 3, and this reduces to 2 square root 3. I'm sorry, 2 square root 2 over 3. That's my cosine theta that I got way back here. Okay, so then you can run through the game of getting tangent, cosecant, and then secant. All right, so just another way, a different way to work the same problem. If you want to use identities, you feel more comfortable doing it like that. Okay, whatever works best for you, that's what you need to do. Okay, so let's do one more problem in that same vein. So given tangent theta equals 1/2 and sine theta is less than 0, the first thing that you need to do is figure out which quadrant you are in. So draw your circle, okay? First step, figure out where you're at. All right, tangent. What type of value is tangent? Tangent is a positive number. It's positive 1/2. All right, all students take calculus. Now, the only places that tangents are positive is in the all, where all of them are positive in quad 1, and then in quad 3 where the tangent and cotangent is positive. Okay, so those are my options. Now, what does it tell me? It tells me sine is negative. So if sine is negative, by golly, I know I'm not in this one because all are positive here. So I know that my theta is going down here. So somehow my theta is going to reach and it's going to wrap around over here. So 1/2. All right. Now let's think about it. Tangent of theta is y over x. So y over x is supposed to be 1 over 2. Okay? 1 over 2. Now, my x value and my y value, are they negative values or are they positive values, right? So if I think about this, when I'm looking at this, which way am I going? I'm going to the left here. So technically, I think my x value is going a -2, and then my y value, it's going down here, so it's going down -1. So both of those are negative, okay? And now all we have left is to find r. Well, I use Pythagorean Theorem. A squared plus b squared equals c squared. Y'all see how it's the same process every time? Step 1, draw your picture, figure out where you're at. Okay, step 2, Pythagorean Theorem. Leg squared plus leg squared equals, and then my r squared, I'm looking for r. So this is 1 plus 4, okay, equals r squared. So I have 5 equals r squared. I take the square root. And so that gets me r equals the square root of 5. This r here is always going to be positive. All right, your r is going to be positive. That's a result of the distance formula, okay? So what does this tell me? This tells me x equals -2, y equals -1, and r equals square root 5. So from this information, I can get all the others. Sine of theta is y over r. Cosine of theta is x over r. Cosecant theta is r over y, and secant theta is r over x. The last one is the cotangent theta, which is x over y. Okay, so x over y, that's just -2 over -1, which is 2. R is square root 5 over x, which is -2. The next one is square root 5 over -1. And if you want to simplify this, guys, you can. That's fine. And then this is x is negative 2 over square root 5. Multiply top and bottom by square root 5 to rationalize the denominator. And then same thing here. It's negative 1 over square root 5. And this reduces to negative square root 5 over 5. So that gets me all of the trigonometric function outputs for that particular angle theta, okay? So if you wanted to, you could apply your Pythagorean identities again. If I have a tangent value, I think back to my tangent. I always think back to the Pythagorean sine squared theta plus cosine squared theta plus 1 or equal to 1. I don't memorize any of them except for this one. I can derive the tangent squared one by dividing through by cosine squared. So sine squared divided by cosine, that gets me the tangent squared, plus 1 equals, and then 1 over cosine squared is secant squared theta. That's how I always think about it, right? However, you can memorize it. I don't care. Just make sure you know it. So I know I was given that tangent theta was equal to 1/2. So tan squared theta is equal to 1/2 squared, which is 1/4. So that's 1/4 plus 1 equals secant squared theta. And so that, what is that? That's 4 over 4. That's 5 over 4 equals secant squared theta. Okay, if I do the reciprocal, here, shoot, I don't know. Do we even need, let's just take the square root. If I take the square root, what am I dealing with? Well, I know that I'm in this quadrant here. That's what I found from my picture. The cosine here, the secant. The only thing that's going to be positive in Q3 is tangent and cotangent. So I know that I'm dealing with a negative value. So I have a negative square root 5 over 2. Okay, so that's my secant there. And then I can use all my properties, from there. I can flip this to get the cosine theta, just do the reciprocal, right? And then you can run through the algebra. At that point, you can get all the other values that you desire. Okay, so you could use, if you wanted to get the sine value, what do you know? You know, like tangent theta is sine theta over cosine theta. Well, you know the tangent was 1/2, and then the cosine was negative 2 over square root 5, and then your sine theta. So if you multiply both sides by 2 over square root 5, those 2's cancel, you get negative 1 over square root 5 equals to your sine theta, okay, which is what you got up there. So just another way to work through it if you want, you need more than one way. Okay, so those two examples, hopefully that helps you out. All right, guys, good luck in your homework.